Hello viewers and welcome to the lesson. I'd like us to work out on this question on shear. This is a question on shear. And this is Kcse 2016 paper 2, question number 23. The question reads, a quadrilateral with vertices A, that is vertices K, 1, L, 4, M, 2, 3, and M, 1, 3 is transformed by a matrix. And this matrix is T is equals to 1, 3, 0, 1 to a quadrilateral KLMN. So this point is supposed to be N, this is N, not M. So that you have KLMN. A, determine the coordinates of the image, 3 marks. Then you have the second question on the grid provided. Draw the object and the image. That is second question. Then we have the other question here. The other question is describe, that is C part 1, describe fully the transformation which maps KLMN onto K prime, L prime, M prime, N prime. Then still the other question is here. Determine the area of the image. And the last question, find the matrix which maps K prime, L prime, M prime, N prime onto KLMN. So that is a question. I'd like us to go to the first part of the question. In the first part of the question, you're supposed to determine the coordinates of the image. You're given the object, KL, the coordinates of the object, and then the matrix of transformation. You're supposed to get the coordinates of the image. Now, given the coordinates of the object and the matrix of transformation, to get the image, we do pre-multiply the object with the matrix of transformation. This is what we mean. We have to start with the matrix, which is T, 1, 0, 3, 1, and then we multiply by the object K, L, M, N, which is 1, 1, 4, 1. These are 2, 3, and 1, 3. And this one should give us the image K prime, L prime, M prime, N prime. I hope and believe that you know how to multiply matrices. This one is done in the earlier chapter. So we multiply row 1, column 1, 1 times 1, which is 1, plus 3 times 1. So that will be 1 plus 3, we get 4. The other one is 1 times 4, that is row 1, column 2. 1 times 4, this is 4 plus 3, which will be 7. The other one is row 1, column 3. This is 1 times 2, 2, plus 3 times 3, which is, so this will be 2 plus 9, which will be 11. So the other one will be 1 plus 9, which will be 10. Then row 2, column 1, you get 0, 1. So this will give 1. The other one will give 1, 3, and 3. So this multiplication is easy. If you have a problem with these, I recommend you go to the early chapter. We've already done these on how to multiply matrices. So those are not coordinates. So you're not supposed to leave the answer like this. The coordinates are supposed to be given like this. K prime, 4, 1. Then L prime, 7, 1. M prime, 11, 3. N prime, 10, 3. So this is how you're supposed to leave the coordinates. So find the coordinates. In the second part, on the grid provided, draw the object and the image. So draw the object and the image. So look at the coordinates of the object to determine the scale, suitable scale that you're going to use here. So you can see the coordinates. The biggest here is 4 in the x-axis. Then for the image, you can see the bigger values are found on the x-axis, 11. So I can use a scale of 2. I can use a scale of 2. I can use a scale of 2. So just take a ruler. And draw. So this is the y-axis. This is the x-axis. I'll use a scale of 2. This is 2, 4, so that it can fit 6, 8, 10, and 12. Then for the y-axis, when I look at these values here, look at these values. They're not quite big, so I can see the biggest is 3. So I can use 2 centimeters to represent 1 dot. This will be 2. This one to be 3. So let me plot the object 1, 1. So 1 is the center here. So 1, 1. So 1 is there. So 1, 1 will be there. So that will be K. Then for L is a 4, 1. 4, 1 is there. So 4, 1 is there. L. Then M is 2, 3. M is 2, 3. 3 is here. M is 2, not 2, 3 is here. 2, 3 is here. So M is here. And then N is 1, 3. 1, 3. 1, 3. So 1, 3 is here, somewhere here. So this is N. So N is very close, as you can see. N is here, M is here, very close. So K 1, 1, L 4, 1, and then M. So we can join these, conjoin them. So conjoin like these. So that is now the object KLMN. So that is the object. Now let's go to the image. The image K is 4, 1. K prime is 4, 1. K prime is 4, 1. So K prime is still there where we have L. And then we have L prime is 7, 1. 7, 1. 7 is between here, 6 and 8. So 7 is here. So that is L prime. Then M prime will be 11, 3. KLM M prime 11, 3. 11 is between 10 and 12. 11, 3 will be here. So 11 is here. 3 is there. This is M prime. Then N prime is 10, 3. This is N prime. N prime is 10, 3. 10, 3 is here. This is N prime. It is there. So we can join. We can join this one. So we have K, and join this one is a straight line here, as you can see. So that is how I join them. So now you have the object and the image. So you have the object and the image, and that's it. You have plotted the object and the image. So we can proceed to the other part of the question. Now, describe fully. This part of the question is describe fully the transformation which maps KLMN to K prime, L prime, N prime, N prime. Now, to describe fully this transformation, you need to have understood all the transformation that we have. We have rotation, we have enlargement, we have translation, all the transformation we learned in Form 2 and Form 4. So just go through them one at a time, looking at this object and the image. And upon that check, there's something that you notice. This one cannot be a rotation. It can't be an enlargement. This one is, it can't be a stretch. So you're left between stretch and shear. But when you look at these, having known the basic properties of a stretch, automatically you can see that this one is a shear, especially looking at the points N to N prime, M, how it has been shifted from M to M prime, then K to K prime, L to, so this one is a shear, where we have, when you look at the areas of these two, notice that there is a variation. So you notice this is a shear, and I've said this, for you to understand the type of transformation, you need to understand all the transformations and their basic properties. That will help you when you look at the object and the image to understand which transformation is this. So this one is a shear. Now, why is it a shear? Because it seems to be an invariant line. There seems to be, when you look at the points, just look at the object points and the image point. And also look at the shape. Is it changing? Look at the area. Is it changing? So the basic properties of a shear, one of them is that the area of the object and the image does not change. How do you describe a shear? Because you have to describe that fully. For you to describe a shear, there are three things that you need to do. You have to give the shear factor. You also need to give the invariant line. Okay. You have to say the shear, then you give the invariant line. And you have to say is when you're describing the invariant line, you say whether it's parallel to the x-axis or to the y-axis. So let us go to the first one. How do you identify the invariant line? How do you identify the invariant line? Now, to identify the invariant line, I'll show you something here. Just pick two lines, that is the object line and the image line. I will pick ML, there's the object line, and I'll pick ML and I'll join it to M prime, L prime, and I'll pick another one, choose any, I'll pick another one, especially the ones that are not on this line, KL prime. So if you pick another one like N, K, you join it to N prime, K prime. Just join. Where they meet, they will always meet on the invariant line. So the first one, like the first one here, ML, you extend this line here, just extend it. If you extend it like this, and then M prime L prime is here, M prime L prime, just extend it here. Look at where they are meeting. The two are meeting at this point. Where they meet, the line on which they meet, that is the invariant line. The line on which they meet, just choose. We've just taken these, ML and M prime L prime. Just extend them. The point of intersection of those two lines is the invariant line. Where they meet, they are meeting on this line, and this line is the x-axis. So that's the easiest way to identify the invariant line. So therefore, the invariant line is the x-axis. Then you can see that this is a shear that is parallel to the x-axis. Look at the shear. It is moving in this direction, or this point, M prime. Look at K. The points are moving in this direction. So it's a shear parallel to the x-axis, N prime, K prime. So you can see the points are moving parallel to the x-axis. Then the next thing is the shear factor. How do you identify the shear factor? Now, the shear factor, this one you have to do some calculation. Just pick the distance from the object to the image. Just choose one point. Choose one point. That is distance from the object to the image. Distance of the object. Distance the object to the image. Then divide that by distance from the object, that object that you've chosen, to the invariant line. This is how you get the shear factor. Just get any point, any object point to its image, then that object divided by distance from that object point to the invariant line. I'll give you an example here. So let me choose the object and the image point. I'll choose M to M prime, M to M prime, M to M prime. What is that distance? Let us calculate that distance. We just count the boxes or the squares. So from M to M prime. So these are 1, 2, 3, 4. This is 1, 2, 3, 4, 5. This is a 4.5. I think this is a 1, 2, 3, 4. This is and then you need to understand that one small square is 2. So when I go, one box represents 2. So this is a 2. This is a 4. This is 6, 8, 9. So from M to M prime, those are 9 units because of my scale. My scale, just understand my scale. My scale is 1 centimeter represents 2. So when I move from M to M prime, 1, 2, 3, 4, these will be 4.5 boxes. Then since the scale is 2, I multiply by 2. So these are 9. So 2, 4, 6, 8, 9. That is 9. Then divided by the object point to the invariant line. So the object point M. So M, look at this, from M to the invariant line. The invariant line is the x-axis. So look at this distance from M to the invariant line. The invariant line is the x-axis. So from M the invariant line, these are just 3 units up. So 1, 2, 3, they're just 3 units from 0 to 3. This distance here is 3. So divide that one by 3, and you get that is how you get the shear factor. So now to describe these fully, you say it is a shear that is parallel to the x-axis. Okay, shear factor of 3, shear factor of 3, of 2, and then the invariant line is the x-axis. You have described that fully by mentioning the shear is parallel to the x-axis, shear factor is 3, the invariant line is the x-axis. That is all about that part. The other part is determine the area of the image. Now, the basic properties of a shear, the object and the image are the same, but there's something else that you can use here by just looking at the matrix of transformation 1, 0, 3, 1, 1, 0, 3, 1, 1, 0, 3, 1. The matrix of transformation gives the area scale factor. When you get the determinant which is 1 times 1, 1 subtract 0, the area scale factor is 1. And remember, the determinant is equivalent to area scale factor. And since the determinant is 1, that means the area of the object and the image does not change if it is 1. So if you take the area scale factor, which is the area of image divided by area of the object, both of them will remain the same. If the area scale factor is 1, then it means there is no change. So the area of the object and the image is the same. So look at this. How do you get the area of the object here? This one is a trapezium. And how do you get the area of a trapezium? A half. Let me just do it here. The area of a trapezium is given by a half the sum of the two parallel sides. Now look at this length. From this is a 2, 3. So that side is 3 plus up there we have 1 unit because of my scale, which is 2. So up there, this side is 1. Those are the two parallel sides times the height. The height is here from 1. This is 1, 2, just 2. So this will give a half times 4 times 2. And so the area is 4 square units. This is a trapezium. Sum of the two parallel sides, half times the sum of the two parallel sides times the height. So therefore, the area is 4 square units. That is the area of the object, which will also be the area of the image. The final question, find the matrix that maps K prime, this is the image, back to the object. So what you do, you let the matrix be represented by A, B, C, D. So you pre-multiply. So you take that matrix A, B, C, and D. Then you have this is K prime, L prime, M prime, N prime. Then this will be mapped back to the object K, L, M, N, like that. So you've already got these. We already got these somewhere. So we have this is a 4, 4, 1, 7, 1, 11, 3, then 10, 3, then 1, 1, This was a 4, 1, 2, 3, 1, 3. So you just need to work out this. So this is the matrix. You pre-multiply it with the image to take you back to the object. So these are you're supposed to get. So this is what you're looking for. So you know how to multiply these. You don't need to do all these. You can take row 1, column 1. This will be A times 4. We have 4A plus B times 1. This is a B. This one should be equivalent to 1. Then you go to row 1, column 2. So this is A times 7, 7A plus B is equals to, this one should be equal to 4. So solve this. You don't need to do the others. This will give you A and B. So subtract to eliminate this simultaneous B. So this is a 4A minus 7A, negative 3A is equals to B minus B will be 0. 1 minus 4, get negative 3. So A will be 1. So if A is 1, just substitute. If A is 1, you get A as 1. Substitute here. 4A plus B is equals to 1. So A is 1. So you have 4 plus B is equals to 1. And so B is equals to minus 3. Now, then you can go to C. And to get C, you go to row 2, column 1. So C times 4, you get 4C plus D times 1, you get D. This one should give you 1. Then row 2, column 2. So this is C times 7, 7C plus D is equals to 1. So eliminate these. This will give 4C minus, eliminating D, negative 3C is equals to 0. So C is equals to 0 in this case. And substituting in one of these equation, when C is 0, use this, substitute in that equation, you get D is equals to 1. Now you have all of them. So the matrix will be A is 1, B. So looking at this now, A is 1, B is negative 3, C is 0, and D is 1. And that is simply how you're supposed to solve that question. Thank you.